Abrasive wear. Abrasive wear occurs when a harder material is rubbing against a softer material. If there are only two rubbing parts involved in the friction process, the wear is called two-body wear. In this case, the wear of the softer material is caused by the asperities on the harder surface. If the wear is caused by a hard particle grid trapped between the rubbing surfaces, it is called three-body wear. The particle may either be free or partially embedded into one of the mating materials. In the micro level, abrasive action results in one of the following wear modes. Flowing, the material is shifted to the sides of the wear groove. The material is not removed from the surface. Cutting, a chip forms in front of the cutting asperity grid. The material is removed, lost from the surface in the volume equal to the volume of the wear track groove. Cracking, brittle fracture. The material cracks in the subsurface region surrounding the wear groove. The volume of the lost material is higher than the volume of the wear track. Abrasive wear, two-body abrasive wear, three-body abrasive wear, adhesive wear. Adhesion wear is a result of micro-junction caused by welding between opposing asperities on the rubbing surfaces of the counterbodies. The load applied to the contacting asperities is so high that they deform and adhere to each other, forming micro joints. The motion of rubbing counterbodies result in rupture of the microjoints. The welded asperity ruptures in the non-deformed, non-cold work regions. When a considerable area of the rubbing surfaces are joined during friction, is a seizure of one of the bodies of the counterbody may occur. The factors decreasing adhesive wear, lower load, harder rubbing materials, contaminated rubbing surfaces, presence of solid lubricants, presence of a lubrication oil, anti-wear additives in oil, adhesive wear, fatigue wear of a material is caused by cycling loading during friction. Fatigue occurs if the applied load is higher than fatigue strength of the material. Fatigue cracks starts at the metal of the material surface and spread to the subsurface regions. The cracks may connect to each other, resulting in separation and lamination of the material pieces. Fatigue wear, fitting fatigue wear, tangential cycling load, fatigue wear of an overlay, normal cycling load. Corrosive wear, wear may be accelerated by corrosion, oxidation of the rubbing surfaces, increased temperature and removal of the protecting oxide films from the surface during the friction promote the oxidation process. A friction provides continuous removal of the oxide film followed by continuous formation of new oxide film. Hard oxide particles removed from the surface and trapped between the sliding surfaces additionally increase the wear rate by 3-body abrasive wear mechanism. Erosive wear. Erosive wear is caused by impingement of particles, solid, liquid, or gaseous, which remove fragments of materials from the surface due to momentum effect. Corrosive wear of engine bearings may be caused by cavitation in the lubrication oil. The cavitation voids bubbles may form when the oil exits from the convergent gap between the bearings and journal surfaces. The oil pressure rapidly drops, providing conditions for void formation. The pressure is lower than the oil vapor pressure. The bubbles voids then collapses, producing a shock wave which removes particles of the bearing material from the bearing. What are the causes for wear? Wear is caused by simultaneous mechanical and thermal stress on the cutting wedge. The major causes are as follows: mechanical abrasion, corrosive, fatigue, adhesion.